Okay, so we have a lot of review things, so like transitive. Do you remember what transitive is? Should we write it down again? So if I have A equals B and B equals C, then what else equals C? So anytime we're taking, okay, these two both equal B, therefore they have to equal each other. That's transitive. Substitution is if we're just plugging it in for something else. So it's not two things equal the same thing, it's just plugging it in. So we often see that with one item. So like if A equals 9 and A plus B equals 20, then I can just plug in 9 plus B equals 20. So that's that difference between our substitution and that. Is the screen too dark? Is this lighting okay? Is that better? Okay. All right, what does bisect mean? Yeah, so that means 1/2 equals the other half. What does perpendicular mean? Perpendicular means 90-degree angles, right? It means that the lines meet at a 90-degree angle. Is that new to you guys?
No.
Okay. So we didn't use that last unit, but you all know what perpendicular means. What is a right angle? 90 degrees. Okay, so we're going to use that, like if they say it's a right angle, then we say, hey, by definition, right angles are 90 degrees. What is congruent? Yeah. So the definition of congruent is used when we're going between the equal sign, saying the lengths are equal, to the segments or angles are congruent. And that's our congruent symbol. All right. Vertical angles congruence theorem. What do you think that is? Are vertical angles congruent? Yeah. So when this is just saying theorem, that's just because we know vertical angles are congruent. If we have a statement saying vertical angles are congruent, then this is our reason. So that just means vertical angles are congruent. All right. All the rest of these are the same thing of just corresponding angles. Are corresponding angles congruent or supplementary? Yeah. So vertical corresponding angles are consecutive or supplementary. So corresponding or congruent. Do you guys know what converse means? So what did converse mean when we were in our yeah. So converse is when we switched it around. And so in the theorems, our converse theorems are when we switch it so lines are parallel. If angles are congruent or supplementary. And we'll look at the diagrams on the next pages, but that's the basic. Anytime you see a converse saying, hey, if these two angles are congruent, does that mean the lines are parallel? Then you'd be using the converse statement. All right, alternate interior angles, congruent or supplementary? Yeah, our congruent ones. Alternate exterior, congruent or supplementary? Congruent. Consecutive interior. Yeah. Supplementary means they add up to what? Yeah. And then consecutive exterior? Also supplementary. What does symmetric mean? Yeah. So if I have AB equals CD, then CDD equals AB. What does reflexive mean? Mm-hmm. So it just equals itself, nothing's changed. Supplementary, y'all just told me, equals 180. What does complementary mean? What's angle addition postulate? Yeah, so that's the part plus part equals the whole. Okay, so this just gives the diagrams if you're forgetting what something is. So corresponding angles, by definition, are congruent. And then the converse is just saying, hey, if we don't know that the lines are parallel, but we know they're congruent, that proves that they're parallel. So all the converse is these angle pairs that are supposed to be congruent. If we know they're congruent, we know the lines are parallel. Is it possible to have alternate exterior angles that are not congruent?
If they're not parallel.
Yeah, so if the lines aren't parallel, then we don't know, that doesn't tell us anything about the angles. So on your notes from last class, or on your assignments, these little arrows in the middle of the line, those mark the lines as parallel. And then you had this section on page 13, if you got to it, where it's asking you, what's the measure that make the lines parallel? So that's just the converse saying, hey, if this is 103, this alternate exterior angle, if the lines are parallel, what would it be? Yeah, so we just say it makes it parallel. If this angle is 103, then those lines are parallel. So it's just a different way of saying it, but it matters in our proofs of, hey, what information do we actually have? And so that's just our converse. And then same with the consecutive angles should be supplementary. And so we need that. Transitive property of parallel lines. So if two lines are parallel to the same line, they have to be parallel to each other. So that's just our basic transitive. If P is parallel to Q and Q is parallel to R and P have to be parallel together. Do you remember if we're on the coordinate plane, do parallel lines have the same slope or different slope? Same, right? So if these were on the coordinate plane, they would all have the same slope, so they all have to be parallel. Okay, next page. Linear pair perpendicular. What does a linear pair add up to? 180, right? So a linear pair is 180. And so if the angles equal each other, they both have to equal 90 degrees. So it's just saying if we have two angles that equal each other and they're a linear pair, obviously they both have to be 90. Perpendicular transversal means if we have parallel lines and one of the angles is marked 90 degrees for us, what are all these other angles then going to be? 90, right? Because they all have to be the same, because if this is 90, the other half has to be 90, and going on. This is just basically the converse. If we know that we have two right angles to a transversal, the lines have to be parallel. It's the only way for that to happen. This was one of your proofs from your last test that you guys went through the steps to prove this. But if we have 3 and 2 are supplementary and 1 and 2 are supplementary, angles 1 and 3 have to be congruent. That's the only way to make that work. And same thing if they're complements. Do y'all remember that proof? That was on your review. Was it on your test also? It might have been on some of the versions. Okay, so let's see now if we can apply it. So proofs were kind of rough for you last unit. Maybe these ones will be a little easier, but do make sure you're doing every bit of practice on the proofs. So if it tells us angle 2 is congruent to angle 8, it would be if their lines are parallel, right? Why? Why would those be parallel? No one? Okay.
Why would 2 and 8?
Yeah, why would 2 and 8 be, sorry, why would 2 and 8 be congruent?
Because they're alternate exterior.
So if it didn't want us to go through this whole method, we could just say, well, these are alternate exterior angles. And then the converse proves if alternate exterior angles are congruent, then the lines have to be parallel. Okay? But they want us to recognize a few angle pairs first. Angle 4 and angle 2, what type of angles are those? So we just write they're vertical angles. Technically, it's a vertical angles theorem. And then what's happening next step? 4 and 8. What do we call that? What did you say? Wait, did we finish this thing? Yeah, that's a transitive. Because angle 8 equals angle 2, angle 4 also equals angle 2, so therefore they equal each other. And so 4 and 8 are what type of angle pair? Yeah. And so this would just be our corresponding. Is it the corresponding theorem or the converse? So we're proving that they're parallel. Is that the converse or the regular theorem? That's the converse. Okay, so make sure you know that clearly. If we know the lines are parallel, the theorem lets us know the angles equal each other or are supplementary. If we're proving lines are parallel, that's the converse. Do we need to add that to our notes page?
Yes.
Okay, so let's go back to our vocab page. So converse is used to prove lines parallel. All right. Our basic theorems, that they don't say converse, so like I guess not basic, our angle theorems. So that means all those angle pairs used to prove angles congruent, or angle measures. When you know the lines are parallel. Yes?
For the first definition of converse, is there another word that we can use to like switch? Because like it's not making sense to me. Like using
So yeah. So switch was what we used when we were in our conditional statements. But it's just is this. So converse proves line, we use the converse when we have to prove that the lines are parallel based on angle measures. We use the basic one to prove the angle measures when you already know the lines are parallel. So what can you guys think? Is there better, is it just easier to memorize that with these statements, or is there a word we can attach that will help you remember? We can't think of a better word. It might just be best to go with these. So converse to prove lines are parallel, the regular one just to prove the angle measures. When you have that, flip on back to page 20 that we were on. Or sorry, 21. Okay, so look at that first proof. Give me a thumbs up, medium, down. How did it feel? Okay, so I have a lot of mediums, a few ups and a few downs. So I'm going to talk through it again and then make sure to ask me after these notes if it still doesn't make sense. So we're looking at our given, and then we're looking at our picture and saying, okay, it wants us to label angles 4 and angle 2 next. And so those are vertical angles. So I'm just looking at, hey, what type of angle pair are these two? How do I know they equal each other? Vertical angles always equal each other. Then I have transitive, which if you don't know transitive by now, talk with me about what you can do to get some review for that. But transitive is anytime I have two different things that equal the same thing, therefore they equal each other. And then I'm just going from, since I know angle 4 equals angle 8, I use my converse proof of saying because 4 and 8 equal each other, they are corresponding angles. And so corresponding angles converse theorem, it would be the one that proves if corresponding angles equal each other, the lines have to be parallel. All right, for our next one, what is that first statement? Given, nice and easy. All right, 3 and 4 are complementary. Oh, that one's given too. What about this one? Angle 3 plus angle 6 equals 90. How would I know that? Yeah. It's definition of complementary because it tells me here, and then that's from the drawing, it tells me this is 90 degrees. And so, sorry, it's not definition of complementary, it's definition of perpendicular. I know that this is a perpendicular line, so 3 plus 6 has to be perpendicular. And so we're taking that from our drawing, from our diagram. And so remember in proofs, what you're doing is always looking at the given, looking at your diagram, see if you can tell, based on this diagram, could I come up with, do I think angle 5 is congruent to angle 6? And sometimes if you just kind of look at that and ignore all the proofs and talk through the steps of, hey, why would these be equal? That can help before you start doing the proof. But we know 3 plus 6 has to equal 90 because the side is 90, and that means the line is perpendicular. All right, angle 3 plus angle 4 equals 90. What would that reason be? Well, so what came right above it? Yeah. So what does complementary mean? Yeah. So when you have a word like complementary, we're going to define it. That means 3 plus 4 has to equal 90. All right, number 5 should be a really easy one by now. What's number 5? Transitive, yep, because 3 plus 4 equals 90, and 3 plus 6 equals 90, so that's just our transitive. All right, how about step 6? That's one we saw a lot last unit. Yeah, we just subtracted the measure of angle 3 from each one. We don't know what the measure of angle 3 is, but whatever number that's representing, we can subtract it from both sides, and we are just left with measure of angle 6 equals measure of angle 4. All right, number 7 should be a really obvious one by now too. What's that one? Yeah, our definition of congruence. All right, angle 5 is congruent to angle 4. Have we seen angle 5 yet? No. So where does it have to be coming from? Either the givens or the drawing, right? Looking at the drawing, do we know that angle 5 equals angle 4? Yes. Yes, how do we know that? Vertical angles always equal each other. No matter what else is happening, vertical angles equal each other. And then number 9. Close. Transitive, because again, we have these two things are both congruent to angle 4, therefore they're congruent to each other. Does that feel better than the proofs we did at the beginning of last unit? Yes. It's starting to make a little more sense. If proofs really didn't make sense last unit, I would strongly recommend you come into tutoring to sit down with one of the advanced geometry teachers and go over them again. Alright, one more proof. So, angle 1 is congruent to angle 2. How do we know that?
Given.
It is given. Angle A is perpendicular to angle C. How do we know that? Sorry, line A is perpendicular to line C. So, angle 1 and angle 2 are what type of angle pair? Supplementary, and then what do we call them when they're supplementary beside each other?
Oh.
But two angles that make a straight line together?
Oh, linear pair.
Linear pair.
We're so dumb.
Okay, so they're linear pair. If we have a linear pair that equal each other, what does each angle have to make? Yeah, so we know that because that's given, we know these are 90-degree angles, which means these lines are perpendicular, right? So this is your linear pair perpendicular theorem. All right, our next statement, C is parallel to D. How do we know that? Just from our drawing, right? So that's just another given. Do you notice in this one, some of our givens are coming from the diagrams? Okay, it didn't say up there that line C is parallel to line D, but it marked it for us in the drawing. And so any statement here, look and see if you can see it straight from the drawing. Is it just another given? All right. What do we know about A and D now? So they're perpendicular. How do we know they have to be perpendicular? Yeah, if these are 90-degree angles and these lines are parallel, so that is our perpendicular transversals theorem. Okay, because if these are parallel, we know that these angles also have to be 90 degrees. Everything's 90 degrees. How would we know that B and D have to be
Given.
They gave it to us. That time it was up there and in the drawing with the square. And so, does A have to be parallel to B? Why? So that's that one called, and you know, I realized these weren't on your basic vocab list, but when we're dealing with perpendiculars, maybe we need to add these to your vocab list. But that's just your lines perpendicular to a transversal. So if we have both the lines are perpendicular to the transversal, then the lines have to be parallel. Do you guys want to add these to your vocab page on page 18? Or do you want to just leave them in the theorems page where they are? Okay. Alright, so once you have that, flip to the next page. You'll probably like these better. Most people do. Alright, you ready? Our recording's still going, you guys. Okay. So, crook problems. You solve crook problems by drawing a parallel line in the middle. Oh, I'm sorry. Thank you. In the crook in the middle. So we're going to come in on each of these and just add our own parallel line in the middle. And that lets us use our angle pairs to figure out what these are. So if this is 54 degrees, what is this little angle here? Is it congruent or supplementary? Yeah, so those are alternate interior angles. That's also 54. So I added my own parallel line, so now I can use angle pairs to figure out, hey, this part's 54. How about down here? If this is 48, what's this part here? 48. Yep. And so then what do I have to do to find angle 1 now? Yeah. So it's just 54 plus 48, which equals what? Is that easier than the proofs? Yeah, so we have to remember we draw the line in, you recognize your angle pairs, and then add them together, or sometimes you'll subtract them to find what you need. Oh, it doesn't look like an obtuse angle. These are not always drawn to scale, so you're right. I'm sorry. Yeah. Okay, so this time, what type of angles would these be from 111 to this side of angle 3? Those are consecutive interior. And so are those congruent or supplementary? Supplementary. So we have to do 180 minus 111. What does that give us? Just 69, right? So 69. How about on this side?
80.
80. And so we're still going to add those together to get our angle. What's 80 plus 69?
149 degrees.
149 degrees. So 800, and then this would be 80 plus 69. Did we do it right?
Yes.
All right, you try. You're going to pause the video. Work on this one in your groups. All right, so you should have drawn your line. Recognize these are supplementary, so that made this one 49, right? We subtract from 180. And then these ones are alternate interior angles. So down here it was our consecutive. So these are alternate interior, which is 59. These are consecutive interior, which are supplementary, and so subtracting it 49. And that's what adds up to 108. Good? Bad? Medium? Okay, we're going to do this last example and then have some time to work. And so, first thing we're going to do, it tells me these lines are parallel, so I know my angles equal each other. I can use angle pairs. I'm going to label this one is x plus 3y. Angle 2 is 2x plus 30. Angle 3 is 5y plus 20. What am I going to have to do to solve? Yeah, I'm going to have to do systems of equations. You guys, this was the last example of last class's notes. Did that one work pretty well for you guys? It wasn't this exact one, but it was systems of equations. Does anyone here think you could solve this on your own at this point?
Yeah.
Okay, so if you think you can, just go ahead and try working through it silently. I'm going to go step by step for the people who need it. So, I have to write myself two equations based on this. So if I start with x plus 3y, is there another angle that equals x plus 3y? Yeah. So those are my corresponding angles. Okay, so the corresponding angles are these two. I'm going to go ahead and simplify by getting my y's together. So minus 3y from each side. So x equals 2y plus 20. Okay, that's one equation. What other equation could I write from here?
2x plus 30
So 2x plus 30, and then what?
plus x plus 3y.
Plus x plus 3y equals 180, because that's a linear pair. Okay. I also could have written one saying 2x plus 30 plus 5y plus 20 equals 180, because those are consecutive interior. So there's 3 options there. I only need 2 equations, so I'm not going to write the third one. All right, and then I'm going to combine like terms. So 3x plus 30 plus 3y equals 180. I'm going to subtract 30 so I get all my numbers on one side. 3x plus 3y equals 150. Alright, so now I have 2 simplified equations. What do I do with them?
You plug the x into the 3x.
Yeah, this is where I do that substitution or elimination that you've learned before. The easiest way is to substitute. I already know x equals this, so I take 2y plus 20 and plug it into the place of x right here. So that gives me 3 parentheses 2y plus 20 plus 3y equals 150. If you can solve it on your own, see if you can get it solved before me. So my first step is distribute. I'm going to go step by step for people who need it. Hey, you guys, the recorder's still going, so stay quiet so people can hear this online if they need to. So 3y plus 6y plus 60 plus 3y equals 150. 9y plus 60 equals 150 minus 60.
I got it.
What'd you get?
2.
For x or y?
Y.
Well, I got y equals 10. Okay.
Oh wait, no, I got it right. I subtracted wrong.
Okay. So if y equals 10, what does x equal?
40.
Yeah, so we plug it back in to right here and say, so 2 times the 10. So I got 10 by solving this out. So 9y plus 60 when I combine it. Subtract 60 from each side to get 9y equals 90. Okay, so then when we plug it in, 2 times 10 is 20 plus 20. So x equals 40. So then my answer would be the ordered pair of 40, 10. Alright, you guys, that was our notes for today.